All right, let's talk about section 10.1. It's an introduction to quadratics and their graphs. And technically we've already started on quadratics because we've done factoring quadratics. And when you see this word quadratic, all you should be thinking is that this problem has an x squared. Now, we're going to start this unit talking about standard form. In standard form, we have y equals ax squared plus bx plus c. Or sometimes I'll replace this y with the function notation f of x. Remember that y and f of x are interchangeable. It's just notation. So things that we're used to seeing, right? Y equals 2x squared plus 4x minus 5. Y equals x squared minus 3. So that this y piece being introduced tells us that we're also going to go back to having graphs. So when we think about the graphs, what are they going to look like? They're going to be U-shaped, and their terminology or the math word for that U-shaped graph is parabola. Parabola. Say it. I know it's corny, but I'm going to make you do it in class too, so say it so you're okay in class. Parabola. Parabola. More than one would be parabolas. Now we need to start with the basics because we always start at the beginning. And when we start with the basics, when we start getting into graphs, we start talking about the parent graphs. Remember that with a line, the parent graph in linear situation was just y equal to x. Just that regular old, plain old y equal to x was the linear example. But now that we're in quadratics, y equals x squared is the parent graph. So that's the one that we compare everything else to. How is it different? How is it the same? So in order to do that, we need to talk about how to graph that parent graph. Like most of the time, we're going to start our first, oops, I didn't want to go that far. We're going to start our first part with how to graph the parent graph. So we're going to create that table. Our normal values we'll go ahead and use, -2, -1, 0, 1, and 2. So when we do -2 squared, we get a +4. Remember that corresponds to the graph, an x value of -2 and a y value of +4. -1 times -1, so that'd be -1 squared. It's going to give you a +1. 0 times 0. And then we get the easy side, 1 times 1, 2 times 2. Now your table didn't have space for it, but we have one more point for this graph that does fit. What is 3 times 3? Yep, it's 9. But -3 times -3 is also +9. So that this U-shaped graph, right, 4 would go to 16. Whoa. This U-shaped graph is called a parabola. And this particular parabola is called the parent graph. It's the one we're going to compare everything else to. We're going to make things wider and skinnier. We're going to move it left and move it right. We're going to move it up and we're going to move it down. And we're going to do all of those things together. So when we talk about the parent graph, or how does it compare to y equals x squared, this is the graph that we want to compare to. Now, I don't want to read all of this to you because I don't think that that's what we need to have. Yeah, I don't need to read this to you. But I do want to point out that, first of all, you need to read it. Every word that I have here is important. Although I have highlighted some, whoops, too far. I have highlighted some that are more important than others. So we're going to talk today about the vertex, the axis of symmetry, the constant, and the a value, or the leading coefficient. The leading coefficient. Again, I really do want you to read about this, but so pause it and read it, because I'm going to assume that you've done that when I move forward. So pause and read. Now you better be back, because now I want to talk about these words. The vertex. Vertex, remember, is the lowest or the highest point. So when we look at the picture, if our U opens up, this is a minimum. And if our U opens, down, like this, sorry, I drew too many. This point up here is considered a maximum because it's a high point. The axis of symmetry is an imaginary vertical line. So when we think about every parabola we're going to draw, they are all going to have an imaginary vertical line that cuts them in half, whether they open up or they open down. There's this imaginary vertical line because they are symmetrical. Remember back in elementary school, that idea of folding up that paper, you put paint on one side and you fold it over and the paint's on both sides because you make a butterfly or whatever shape it is. That idea of symmetry happens in a parabola. This constant, that's that C value, is always going to be the y-intercept. It's always going to happen. When I plug in a 0 for x, I'm going to get the C value as that ordered pair, right? That's the definition of a y-intercept. Now the A value is probably one that's the most important to us a lot of the time because it tells us two pieces of information. It tells us, well, remember that's the leading coefficient. That's that number in front when I'm in descending power. It's going to tell me whether my parabola is a maximum or a minimum. If the A value is greater than 0, means that if the A value is positive, then my quadratic opens up like this. And the vertex, that's this point down here, is a low point or a minimum. If the A value is less than 0, it's telling me that the A value is negative. Then the quadratic will open down, so it faces this way. And the vertex, that's this point, will be a maximum. So let's go to the how-tos. I'm going to restart my video just in case I get a little long. This would be a good place to stop, just in case.